Hey Nano fam, welcome back to another live stream. This time with a new setup. Let's see. I'm getting frame drops here, so maybe this new setup is not that good yet. Can you please just give me a quick feedback if the stream is okay? Like the frame drop rate is huge. Yeah, because I investigated it a bit last time. My computer was so horribly slow, and then I bought a capture card, and now I'm using two PCs, one for working and one for streaming. And the reason why my PC was so horribly slow is because it has an overheating problem. I think the fan is not working well, and when I ran OBS and everything, and I compiled and stuff, it got to close to 100 degrees, and then it shut down. The CPU got really slow then. But now I'm using two computers, and let's hope that this works well. But I'm a bit worried now because my streaming PC is getting a lot of frame drops, and it has a very weak wireless Wi-Fi connection, even though the router is right behind me. So yeah, so if you're getting frame drops, let me know, and I restart the stream, and I use a cable connection, and I'm going to set up a cable connection. Okay, so today is a bit different from the streaming time, as you saw. Hey Forrest, nice that you're here. Welcome. Today I'm streaming a bit earlier, and I don't know how long, so my goal was maybe 3 or 4 hours, so this is a longer stream, but let me warn you, this will be the most boring stream on Twitch, I think, and on YouTube, because of what I'm going to do today. Well, in the first small part, I'm just going to show you what I did since the last stream, and then I'm going to debug the async runtime, and that is just a very boring task, finding a bug, but yeah, it's part of this job too. So if you're having trouble sleeping, watch this stream, or I warn you when the boring part starts, and you can just close it or whatever. Yeah. So my chat window is now on the other side. So Forrest says quality is superb. Oh, that's good. Yeah, frame drop rate is at 8%, says my computer. Turned your stream into a perceived faucet stream so people can watch and earn Nano at the same time. Oh, cool! That's possible. You can just pick one stream and turn it into a perceived stream. Great. Can you post the link? All right. So, yeah, let's start. Yeah, so first thing I wanted to tell you is that I'm trying my new streaming setup today, so probably will or I hope there won't be any bad surprises there. But so far it looks good. I'm really happy about this because now I can use like all cores of my laptop, and I hope I don't have to have this horrible lag from last time, and it can work. I hopefully can work a lot quicker this time. Yeah, so the next thing is I'm super excited about that. There will be another podcast, a Nano Community Initiatives podcast on Twitter, and this we have it here. So this will be coming Saturday, September the 9th at 8 p.m. UTC, and I will be talking about RS Nano there, and this is not as technical as this stream, because like on this stream I actually do like development work, and on this podcast I'll try to answer your questions and like why I'm doing this, why Rust, or if you have any questions you like to get answered, just you can just write it in chat or on Discord. Andifnal says, I've already set an appointment. Cool. Yeah, really excited about that one. Yeah, Also, Pim from the Nano Foundation will be presenting Ririro, or I don't know how to pronounce it. So, yeah, so that's coming up. Then, since the last stream, I don't know, you probably have seen that already, but I just wanted to show it. This cool new site, and its name is nanospeed.info. And I should have written down the name of the guy who did it, made it. So this is a cool new site where we can just see the speed of Nano, the confirmation times, and cool graphics and live data from the network. So that's really cool. Nanospeed.info. And yeah, and I wanted to say thank you to the person who delegated 100,000 nanos to my rep this week. Maybe he's watching, or she. So thank you for that. Okay, what else? Yeah, so let's just browse the commits I made during the last week. And then let's dive into the async stuff of Nano. So I haven't looked at this myself. So, oh yeah, and we have problems with the tests. Yeah, I should spend some time there too. So I got a lot of stuff done, and it was mostly all of it was related to networking code. And so I got to the point that all network-related classes are now in Rust, except for the actual async runtime. And yeah, so then I decided to tackle the runtime itself. And I think this will be the most difficult part of porting Nano to Rust right now, like switching from the C++ Boost async runtime to Rust Tokyo runtime, because it's just two very different runtimes, and I want to do this not in one big bang, but I want to do this gradually. And I think it is possible, or I actually made significant progress there, but yeah, I'll show you. So what I did, or I wanted to draw a small diagram so that you can see what I'm talking about. Yeah, so where do we start? So let's start with how the Nano node worked before I changed anything. So there was a class called socket, which represented like a socket TCP socket connection, and the node uses sockets to communicate with other nodes. And the way it was before I changed anything is there was this socket class, and it directly used the boost IO context, something like that. I think IO context is the name. And that is from the boost library, C++ library, and it offers async capabilities. And it does that with callbacks. So you say something like async, or let's add it here. Async connect was a function, and async read, async write, async read, async write. And what you would do is you would give callbacks to these functions, and once the read, the write, the connect, whatever was finished, your callback would be called. And this is how the boost async stuff works. And currently RS Nano still uses that. And the way I made the first changes here, so this is like a history lesson now of what I did during the last year. So yeah, let's add a text here. So this is C++. Ooh, XL. So this is the C++ side, and down here will be the Rust side. So what I did is, first of all, the socket used the boost stuff directly, and And the first change I made is I removed that direct usage and I introduced an intermediary class that would encapsulate the boost stuff. And I called this class TCP. Oh, what? Oh, something crashed. My browser crashed. Ah, but that's not good because I'm using two computers. So my browser crashed on my dev machine, but the stream still works. That's cool. Yeah, so where was I? Yeah, I introduced an intermediary class, and that was called TCP. Oh, font size is too big. TCP socket facade, I think was the name. Like that. And can we add a bit of space? TCP socket facade, and the TCP socket facade would just make all of these boost async calls. And then all of the sockets and everything that worked with networking code would then just use the facade class. And the reason I did that was so that I can replace the async implementation later. And also that I can use it from Rust. So that was my first thought. Oh, I just saw a frame drop. Did you have a frame drop, chat? Yeah, next time I'm not using the wireless, the Wi-Fi. Where's the music? Yeah, here it is. Okay. So yeah, first thing I did was I introduced a socket struct on the Rust side. Socket. And I gave a socket handle from C++ to Rust. So whenever we created a socket on the Rust side, we would create a socket instance. Whenever we created a socket on the C++ side, we would also create a socket instance on the Rust side. And on the Rust side, I introduced a trait called TCP socket facade as well. And the socket would have access to that. And then there was the FFI implementation of the TCP socket facade. I called it FFI socket facade or TCP socket facade. Doesn't matter. I think this is the name. And this one implemented the trait, and it had for callbacks. It had a pointer to the C++ side. So let's make the C++ side a different color and the Rust side a different color. The red green. So red is C++, green is Rust. Okay. So that was the first step. And then I just moved gradually all of the socket code to Rust. And when all of that was done, I could remove that arrow here. And so basically the C++ socket class did not have anything in it. Like it would delegate all its logic, all its calls. It would delegate everything to Rust, and Rust would do a callback to the C++ side whenever it needed to do an async read or async connect and async write. And it used the TCP socket facade for that. So that was the status quo. So this was how it was until last week or the week before. And then I decided to move the async runtime to Rust and Tokyo, and to do it gradually. And for that, I introduced another class on the C++ side, and I called this async runtime. So let's add this class here. It was called async runtime, and it was just a data structure. Let's make it red because it is C++. Because it is C++. And it would have two instances or two fields, two members. One was the boost IO context that we already had before. And the other one was a handle or like a pointer to a Tokyo runtime. So let's do that here, like Tokyo runtime. And that changed, like it did not really change anything except for whenever we created a runtime, an async runtime on C++, so that we would create a boost IO context, and at the same time we would also create a Tokyo runtime in parallel. And that Tokyo runtime was not used, it was just created when the boost IO context was created, and it was destroyed when the boost IO context was destroyed. And then my plan was to bring this TCP socket facade to Rust and to make it use the Tokyo runtime instead of the boost IO context. And so in order to do that, I created another struct on Rust, on the Rust side, and that one is called Tokyo socket facade. And Tokyo socket facade also implements the trait TCP socket facade, like that, and it has an arc to the Tokyo runtime. And so the diagram, as you see it now, that's how things are right now. So right now we have the FFI socket facade, which still uses the C++ runtime, and we have the Tokyo socket facade, which uses Tokyo as a runtime. And now comes the really cool part, because I did not want to like break everything and switch to the Tokyo runtime, and then nothing worked, and I was like didn't have a running node anymore. So I introduced an environment variable. So when that environment variable was set, it would use Tokyo runtime, and if it was not set, it would use the boost runtime. And with that, I can now very quickly switch between the C++ runtime and between the Rust runtime. And this environment variable is called Nano enable Tokyo, I think. I think this is the name. So if that is set to 1, it uses Tokyo. And if it is set to 0, it doesn't use Tokyo. And I wanted to show you that right now. Oh, and I totally forgot to show you my new editor. I switched to NeoVim because, because I was a Vim user in the past, years ago, and I loved it. And I never managed I never took the time to configure NeoVim because it's so much work to configure it. But after the last stream and after everything was so slow, I finally took some time and I configured NeoVim, and it works really well. So now I have code completion for C++ and for Rust at the same time. It works really well, really fast. And now NeoVim is my new editor, and I'm not using Visual Studio Code anymore. So I'm really happy with this setup. Underfloor says, yeah, you know what NeoVim gives you superpowers? Yeah, I don't know about that, but I love it. Like I'm a huge Vim fan. I was that in the past, and then I had some years now where I didn't use Vim. And I'm really happy to be back on the Vim side. So yeah, and I'm using Tmux, so I can switch between the terminals quickly. So I'm so this is the terminal and I'm in the build folder. So when we run the test, like this, core test, it will just use the C++ runtime, as you see. And let's cancel them. And when we say nano enable Tokyo, and we run the tests, it will use the Tokyo runtime. And now this is the thing. This is the thing why I say this will be the most boring stream on Twitch. See, it fails. And roughly half of the tests fail when we use the Tokyo runtime. And I have no idea why. And today I want to try and find out why they fail. And this is probably just me looking at the code and cursing, not doing anything. And maybe we won't even find anything in the next hours. So just be warned, this is, yeah, the most boring stream you will ever watch. So if you want to now close it, do it now, because it won't get better. Yeah. So let's start. Underflow says, if it was a PHP bug, I would suggest VS Code with Xdebug, but I'm lost in Rust. Sorry. Yeah, so I'm actually not good at debugging, really, because usually I work test driven and I have many unit tests, and if there's a bug, it is usually obvious, because you change a line of code and then some tests fail, and you know why they fail, because you changed one line of code and then you can just figure out quickly why there's a bug. And so I'm not very used to debugging, and I'm not good at it at all. Yeah, but I have to fix this issue, or otherwise, yeah, I can't go on, really. And this will be, as I said, this will be probably the most difficult part of porting Nano to Rust, switching the async runtime. Yeah, so I ran the test before and I saw that there are tests just for networking or sockets networking. So let's just run those. Was it networking or socket? Let's see, socket. Let's only run tests with the name socket in them. And as you can see, there are tests that pass. So it's not completely wrong, the Tokyo runtime. And we had a test failure here. Yeah, socket drop policy fails. Yeah, this one I investigated yesterday evening. And it is a difference in how async write and async read work in Rust and C++ or in Boost. So what I saw there was, and I'm not sure if that is correct, but what I saw there is, if in Boost I say async write, so I write some bytes to the network, and the remote end point does not read them, it just stops there, I think. And on the Rust side, it just pushes the bytes into a buffer and says everything is okay, everything went out. And that is why these drop tests fail. And this is, I don't think this is a serious issue, really. So I don't want to look at that failing test. Oh, this was the only failing test on the sockets, for the sockets. Okay. Then let's run the network. All tests with the name network in them. Yeah, receive weight change. Yesterday evening, that one failed. And I had a look at this test and I have no idea what it does, or it is very complex. So what's going on under the hood? Yeah, so this test here that failed, the peer max TCP attempts. I think this is a good candidate to look at. Peer max TCP attempts. And while those tests run, while those tests run, I want to show you the Tokyo socket facade, which is really ugly code right now, but I just wanted to get it to work first before I clean it up. So this is the class, TCP socket facade. And so what it does, it just emulates the behavior of Boost. For example, async connect, you would give it the endpoint you want to connect to and a callback that is called whenever the connection was successful or failed. And so this is now like emulation code where we spawn a task on the Tokyo runtime, and once we are connected, here's the TCP stream connect call. Once we are connected, we switch to, so we make a thread switch here. So this is just for me to be cautious because I don't know what's happening in the callback, and there could be blocking calls in the callback, so I'm extra cautious here. And I just do a spawn blocking whenever I call callbacks, so that I don't have to worry about what's happening in the callbacks, and they can do blocking calls or whatever. And same thing when the connection fails, we just call the callback with spawn blocking. Same style for async read. We just switch to the Tokyo runtime. We wait until the stream is readable. Oops. We read from the stream, and then we make a spawn blocking, so we switch to the blocking thread pool, and we call the callback. And async read 2 is just the same thing, just a different data structure. That I needed this for communicating with C++. Async write, the exact same thing. Async accept is for accepting TCP connections, so also the same thing. It just launches a TCP listener. Where is the TCP listener? Or maybe it was launched already. And whenever we have a connection here, we call the callbacks, and we do these callbacks also on the blocking thread pool. So yeah, so that's it basically. That's the current state. This is the whole struct here. That's it. And it works. Some tests work and some tests don't work. And so let's just run the peer max TCP attempts test. Peer max TCP attempts. And let's find out why this test fails. So it fails because it says it expected network size to be 0, but it was 19. So that's strange already. 0 and 19 is a very different number. So let's go to this test. Which file is it in? Does it say? Yeah, network CPP. Okay. So let's go to network CPP, and let's search for here max. There it is. This is the test which fails, and it's not big, just a couple of lines. That's good. And this is the line that fails. Network size should be 0, but it was 19. And now let the boring part start. And if chat, if you have any idea like how we could improve the debugging technique, please let me know, because as I said, I'm not good at debugging at all. So what I usually do is I just add some print statements and I get an understanding of what happens, and then I find the bug with the print statements. And I know this is just a really dumb technique, but please let me know if you have a better idea. Okay, Network size is 19. So what does the test do? It starts a test system. It adds a node. And then it adds many nodes and starts them. And then it calls network merge peer. Okay. So first thing I want to know is how many nodes are being started. So let's just print that one. Maybe this is, I want to know where the number 19 comes from. So my suspicion is that maybe that is close to 19 or something. So let's just print the value of max peers per IAP. And let's compile. And as you can see, it's now much faster. I'm using all cores. I have don't have to wait because of OBS and anything. Linking. Okay, let's run the test. 20. Okay, so max peers per IP is 20. And for some reason, the network size is 19. So for some reason, every node that we start, in here is counted in the network size. And I wonder why. So let's remove this print line again, and let's have a look at what does network size return actually. So let's go there. TCP channel size. What does TCP channels size do? Oh, okay, so this goes now to the Rust side, of course. So let's go to TCP channels, the Rust implementation. And my guess is size. Come on. Or maybe it's called len. No, let's go to the FFI part first, TCP channels. And let's have a look at what it calls. Where is it? What was the function name? I forgot. Was it like channel size or something? Channels, size, len, count. Okay, let's go back to the C++. And let's look at what it calls RSN TCP channels count, channel count. So let's search for channel count. Here it is. So what it does, it goes to TCP channels and it goes to len. Here. This is the function that counts the channels by endpoint. And by endpoint is, I think, just a hash map or something like this. Yeah, hash map. So that means we inserted the channel into our TCP channels instance, which has a channel container inside. Of course, there's got a bunch of people watching via PC. Great. How many? And how much do you pay out? So maybe I should watch my own stream. Okay. I really can't believe that people watch this, because it will be like this for the next 3 hours. Like me just browsing through the code, having no idea why the tests fail. Only like 3 or 4, but it's something. Yeah, it's something. I mean, not many people are watching here either. I'm paying 0.001 on perceived per second. Cool. So you have to deposit nanos there, and then those nanos get paid out. They get paid out to the viewers, right? So hello to all viewers on Perceive. Okay, so where was I? So it's the channel is in our TCP channels instance. Or says, yep, it's paying the viewers every few seconds. Great. Really cool idea. Maybe if I could hook it up. Or how did you do that? Like how are you restreaming it on Perceive? Do you need any special software for this? So there's an insert. So I want to try something here. I want to find out what's the difference between the C++ version and the Rust version. So my guess is that for some reason on Rust there will be an insert and there won't be an insert on C++. So let's add a print line here and let's say channel inserted into TCP channels. And let's, can we like print some more information here maybe? Can we, what is the wrapper? What does the wrapper contain? It has the endpoint. The endpoint. Yeah, let's just, or is that, no, the endpoint should be the same all the time, I guess. Because they are all connecting to the same. Can I have like something else like local endpoint or IP? What else does it have? Node ID, IP address, subnetwork, endpoint. Yeah, you know what? Let's just print the endpoint and let's print. Yeah, I just want to see if there's a difference there. If we insert the channel, is that a method? Yeah. So now let's build again. Forrest says, wait, no. Oh, lots of new messages. Okay, here Andif now says, Forrest, shouldn't be the other way around with the paying. Yeah, Forrest says, we made some changes, so now you just add a YouTube link and streams it through. Cool, that's cool. Forrest says, we have two functions now. We can either pay viewers for watching or get paid by viewers. Two functionalities, yeah. This moment I'm paying viewers because I want them to watch the stream and I want to spread Nano around the globe. Yeah, that's also like why I do these giveaways, because I'm not streaming to earn money, but I'm streaming to show Nano, to show the community that Nano is alive and what I'm working on, and also like maybe some viewers have not used Nano yet, and so they get a chance to get a Nano and play around with it. Okay. So yeah, Forrest, give me your Nano address. I'm tipping you 1 Nano that you can push into your Perceive stream. So yeah, so it was the building went well. So let's run the test. First, let's run it with Tokyo. Okay, channels inserted. That seems more than 20 channels. And it is different ports. Maybe I should also print the node ID or whatever where this message came from. Now let's run the same test without Tokyo. Huh. There's the difference. So on the C++ side, we never even insert a single channel. And on Rust, we insert many channels. Horses loving the Nanomac, by the way. What's the drink this time? Oh, you got me. Usually there's water in it, but not today. You got me. It's beer. Yeah, it's hot again. I decided I would put a beer in it, and I hope no one would ask. Okay, so that's the difference. So what? I don't know what is that? Oh, is that the Primogen? I love this guy. I watch his streams. So Forest Nano address, here it is. Let's copy that. And let's go to Alt. And let's say send, copy one, send. Yeah. There you go. Okay. So there's not a single channel. Yeah, you're welcome. There's not a single channel inserted when we use the C++ runtime. There's many channels being inserted when we use the Tokyo runtime. So let's go one step higher. And let's try to find, let's see who calls insert. What's going on? Okay, so we have two usages of insert. We have one usage here in, what is this? Insert, where are we? TCP channels. Okay, and what is the other usage? Oh, the other, this is not a usage, this is an implementation. So we have only one usage of insert. And it is here. So maybe we can find out. Yeah, let's add the print statement here to this insert. So channel inserted into TCP channels. Let's channel.endpoint. No endpoint in channel enum. Okay. Let's put it down here because then we have a TCP channel, and we can say TCP channel remote endpoint, and we also have the local endpoint. Or what else do we have? We have the remote endpoint, we have the local endpoint, peering endpoint. Do we have the node ID or something like that? Yeah, let's write the remote endpoint, and let's also write out the local endpoint. TCP channel local endpoint. Yep, let's compile. And let's see. So this is my plan, like going in those small steps. Very, very slowly, getting closer to the core of the problem. Except you have a better idea, chat. So let's run the test. Let's run it with Rust. Yeah, so a lot of inserts. Let's run it with C++. No inserts. Okay. Forrest says, Nano really makes currency fun. You sent me one Nano which is then sent to people around the globe watching your live stream. How cool is that? All happening at the same time, basically. Yeah, that's futuristic. Like, that's how money should work. Forrest says, thanks for putting in all the effort to port Nano to Rust. Yeah, it is. I think I will be talking about this on the Nano community initiatives on Saturday, because like people say, like, I put in so much effort and work, and I don't even see it like that. For me, this is not effort. This is not something I have to force myself to do. It's the other way. I can't stop myself from doing it. Handelfmal says, well, that's life. Debug, fix, repeat. Yeah. So you don't have a better suggestion too? Yeah, then let's keep going. I'm sure there must be a quicker and better way. But as I said, I'm not very experienced at all with debugging. Okay, so let's go one step higher. So now we know we still have a lot of inserts with Rust and no inserts with C++. So let's remove the print line. And let's find all usages of this insert. And we have one here in the function process message. And we have another one here in the function start TCP receive node ID. So maybe we add a print line on both sides so that we know where the insert comes from. So let's say we add a print line here. We say insert channel from, what was the function name? Process message. Oops, where is it? From process message. And let's also add a print line here. And this is insert channel from start TCP receive, what was the name? Node ID or something like that. And let's build again. Okay, frame drop rate went down significantly. That's good. Okay, compiled. So, of course, there are no inserts on C++. And so on Rust says, oh, there are inserts from both start TCP receive node ID and from the other function. That's interesting. Huh. I wouldn't have expected that. So, where to look next? Maybe let's go back to the test. And I want to see, so it must have to do something with this merge peer call, I guess. So if we comment this line out, then it should pass. My guess. So maybe, so there's two ways we could go. We could go bottom up, what we just did, or we could go top down. And I just want to have a quick look at the top down, because maybe that is the faster way to find the problem. Linking. Okay, yeah, so this is now a different error. So this test failed because the reach out failed, and that's okay, but the network size was 0. So it, for some reason, the merge peer call causes the channels to be added, but only on when we use the Rust runtime. So maybe let's also add print statements here. Oh no, this is C++. We have to say cout merge peer, and we give the peer, and then we say, we also add a print statement when the reach out didn't work. Then it says stuff. So let's say, what do we say here? So reach out. Oh, does the bool value we return, does it mean it was successful or it failed? Because Nano uses this convention that bool return values, they are true if it failed, and they are false if it worked. And this, I find this very confusing. So let's say reach out returned true. Let's build. Yeah, this is the most boring part about programming. So if you have to have something that some very deeply hidden bug like that, and you have to find it, I don't like this at all. And if you would just have like more fine-grained tests that would, yeah, just test for that. There must be some behavior now that's different between the C++ and the Rust side. And we have to find that. What? The output is... There's no output? What's wrong? There should be a print line. What am I missing? Merge peer. There was no line that said merge peer. But why? Let's go back. Oh, I did not. Oh, I did not save. I did not save this file where I uncommented the line again. Let's compile again. Yeah, compilation was only faster, then this whole process would be a lot faster. Where I change a line of code and I want to see the changes it makes. Patrick says hi. Hi, Patrick. So we are working on Nano, like the cryptocurrency Nano, and we are porting it from C++ to Rust. And we made good progress, actually. So a couple of days ago, I tweeted that we are at 40% Rust now. And let's just check how much we have. I have this script here. Oh, you didn't see it again. I have the script here, % Rust, and it says 40.37%. So Rust code base is 57,000 lines roughly. And yeah, we have 40% ported. Okay, so compilation succeeded. Let's run the tests again. And there's a lot of output. Insert channel. So there's many merge pure calls. And this was with Rust. So let's run the same test with the C++ runtime. And this looks different. Reach out, return true, reach out, return true. And what? Let's just look at the Rust thing one more time. This says Ral121, hello there, hey. What are you doing? Yeah, so let's just interrupt this and let's just quickly talk about what we're doing here. So this stream is about the project RS Nano. So you can find more information on rsnano.com. This is a port of the Nano cryptocurrency. And Nano is written in C++. And what I've been working on is I've been porting it to Rust. for quite a bit of time now. I think it's, I don't know, 2 years now. And I'm tracking the progress here. So every month I count the lines of C++ and the lines of Rust and update this diagram. And yeah, I think I actually started in 2021, but I did not spend much time with it. This was a real hobby, and or really just a hobby where I put a couple of hours at most per week of work in it, and then I went crazy with this project in March 2022, and now I spent a significant amount of time with porting Nano to Rust. And I do this gradually, so the node is in a working condition all of the time, and now I'm working on the most difficult part, which is I'm switching the async runtime from C++ Boost to Rust and Tokyo, and this is a huge change. And if we manage to finish this migration, then everything else is just easy. Or not easy, but everything else is just yeah, business as usual. And this here is right now is the most difficult thing of this whole porting project. Yeah, so you can find more information on rsnano.com, or if you want to find out more about Nano, go to nano.org. This website here. All right. So yeah, and this, as I said earlier, this is like a really boring stream today because I'm trying to find a bug. Or it's probably even more than one bug, because I implemented a wrapper or an emulator, let's say, for the Boost C++ async runtime that runs in Tokyo, and it doesn't work well. There's some issues there. And I'm trying to find all of the bugs now, one by one. Hey, Vivax3794, hey. Everything should be Rust. Yeah, Rust is so cool. Like, it just gets rid of a whole category of bugs. All of those memory errors gone, and it's so much more difficult to write buggy software in Rust than it is in other languages. Of course, you could still do it, but yeah, Rust is a huge help in writing stable or yeah, bug-free software. So let's go back to, oh, here we are, where the test output, and let's just scroll through the test output. So it said merge pure, merge pure, merge pure, merge pure, but it never says the line merge pure return true. So it never, why? And the C++ code always says merge pure return true. So we have a difference there already. So this is a good place to start now. So can we adjust the output? So we are in the merge pure. So both Rust and C++ print this line, but only the C++ runtime says reach out return true. So let's remove those outputs and let's go to reach out and let's find out what's the difference here. Yeah, as I said before, this is what I said before on the Nano convention is to return true if it fails, which is just, yeah, really confusing. So that must mean that let's add a print statement here where we say reach out error is error. And let's also log the error after this line. Returned. Okay. compile again. And there will be a difference here. So, Vivek says, I'm personally working on a web framework in Rust. Cool. Web framework in Rust. Share. Can you share it? What's the name? Forrest says, Crypto 5 Story asked, what programming environment are you using? Amazed you can run C++ and Rust. So I have switched now to NeoVim, and I made the switch last week. So I work with, if you watch my older streams, I work with Visual Studio Code, which works really well. So I was actually very happy with it, but I am a Vim guy by heart, and I have not used Vim for many years now, and I always wanted to go back to Vim. And last week I made the switch from Visual Studio Code to Vim, NeoVim, and I'm still getting used to it. So if you haven't worked with Vim for a couple of years, it's yeah, I'm still learning it or tweaking it. But so far I'm really happy with this. Vivek says, not published a version yet, still working towards that. A few features I still want to implement before I do that, as well as writing some docs. Yeah, but what's the name? Can you share the name? So let's run the tests again. Let's run the tests with Rust. And it says, let's see, it says, reach out error is 1. TCP channels reach out returned 1. So sometimes, that's interesting. Vivek says, calling it Fluent Web, though, you won't find any results for that in Google. Okay, cool, yeah, but maybe one day I will. Then I will remember. TCP channels reach out returned 1. Reach out error is 0. So let's run the C++ version. So, and to all the new viewers, so what I do here is there's these original unit tests from C++, and I run them, and I can switch between the Tokyo runtime and the Boost runtime just with this environment. I hate this word. Just with this environment variable called nano enable Tokyo. So if it is 0, it uses C++ Boost, and if it is 1, it uses Tokyo and Rust. Oh, what was that sound? I've got a new follower, thanks. Oh, I was too slow, I couldn't. Where can I see the names? I don't know. But thanks for the follow. Okay. So, did I... Yeah, okay, so this always returns 0. See, when we run it with C++, it always returns 0. And when we run it with... If we run it with Tokyo, we get a couple of 1s. So that means errors. So let's find out why we get errors here. So both functions here return errors. So the not appear returns errors and the reach out returns errors. So let's focus on the first one. Why does not appear return errors? So maybe I want to comment this out, and because I just want to focus on this part first. So we are in not appear. Let's change that. TCP channels not appear returned error or endpoint. Oop. Just want to have more data. By the way, if you're looking for like a cool, unusual book, let's say you have a problem you want to solve and the problem is difficult. I got the book recommendation from Gregory Young, and it is a really old book, and it is called How to Solve It, and it's a book from a mathematician, and it is a pretty old book, I guess. When was it written? 1945. So this is it, a really old book from a mathematician, and this book is about how to solve difficult problems, and a really good read. So if you're interested in book recommendations, like unusual ones. And this really helped me like improve some things in my work, because we programmers, we often have to find solutions to difficult problems, and that book is really cool because it looks at it from the mathematical position. And I just thought of this book when I said I need more data, because that's just something in this book where it focuses on what data do we have and what can we do to get more data. So, Alan Abrahau. Hi everyone. And Twitch has more than 1 second lag. Yeah, but I think it's not Twitch, it's Restream, because I use Restream.io, and that pushes the stream to Twitch and to YouTube, and I think that this just introduces a bit of lag. What do you guys think? Like, do you use YouTube? Do you use Twitch? Is it worth it to stream on both platforms, or should I only use Twitch? Because I could also just stream on Twitch and later upload the video to YouTube from Twitch. That's also possible. And then I think the lag would be better. So let's compile this. Yeah, I'm really baffled. Like, still people watching this. Me stumbling through the code. And my plan is to do this for the next couple of hours. Mike says, I don't like watching streams on YouTube. Their interface isn't as nice, in my opinion. Yeah, I think Twitch is much better for live streaming. Yeah, me too. Or says, at least keep using YouTube until we can restream to perceive from Twitch. Ah, okay, yeah, yeah, that's a reason. There's continuously a bunch of people watching on Perceive, so it's a nice extra. Yeah. Let's run the tests. So, I made a mistake here with the print statements. What is this? Okay, this looks strange already. Do you see this, chat? Do you see? Can I mark you? No. This is not a valid IP address. Ah. And yeah, so there is, I think we are getting closer. So there are calls where the IP address is not valid. And those calls return error. So one is false, one is true. So that means error. So all of those cases where there's the IP address is not valid, we get an error. So let's quickly run the test with C++. And we only have valid IP addresses there. So for some reason we're getting invalid IP addresses. So why? So that's endpoint. The endpoint is incorrect. So let's go one step higher again. Let's go to the caller of reach out. Oh, wait a second. I have to go to... No, I have to go to the test. Here's the test. This is where it calls merge peer. Let's go back and let's print the endpoint. Maybe that is the problem. So let's say node to network endpoint. So this must be, for some reason, this must be an invalid IP address. And let's add some text here, and that text is node endpoint is, let's build. Anders now says, this is why I love watching code debugging. You do love watching code debugging? I have never watched someone else debug code, I think. Because for me, this is just really boring. Like, I love to write code. I love to think about design and architecture, stuff like that. But this here, like adding a print line here and running it, adding a print line there and running it, I find this incredibly boring. And I can't believe you guys are watching this. Yeah, Diffnal says, yes, even though I don't know Rust. Okay, so running the tests and... Oh, I didn't... Did I not remove the other write lines? I didn't save. Let's compile again. And if not, I tried to grasp it. You tried to grasp Rust? I think Rust is really difficult in the beginning. At least it was for me. But once there's this moment where, this moment where you really get what the borrow checker wants from you, and then it just gets a lot easier. So, insert channel from... Which file does still have these print statements? Oh, the Rust part. Let's remove that. I just want to have the print statements that I care about. So I still have in here. Print. Yeah, let's remove all of these print statements. Like that. Let's recompile. Let's go back to test. Okay. But these were all valid IP addresses. What? What? All of these IP addresses are valid. Let's go to the merge peer function one more time. I think I made a mistake. What? Let's go there again. Calling. Reach out with here A. And then, because this returned false because it got an invalid IP address. Maybe it was called from a different place. Yeah, because there's more places where we call merge peer. There's more places where we call that. Let's run that again. Yeah. Okay. Let's run it with C++. Okay. So our test calls it with the correct IP addresses. But who is responsible for calling it with the incorrect IP addresses? Let's see, where could this come from? Node entry CPP. Or just, I don't think entry CPP is, I think, for the daemon. Then with bootstrap CPP. Okay, I'm going to add print statements everywhere. Then we will know. Merge peer from Bootstrap initiator. Okay, and let's go to this place. Here we call merge peer from keep alive. Network keep alive. And then we have one here. Merge peer from network merge peers. And this is yeah, I think that was it. Save. Build. And if not this backtrace. Yeah, how that would be cool. Like how could I do that? How could I print a backtrace? Do you know? Thing is just I'm not really a C++ dev, so like printing a backtrace, I would do how to do it. Throw a panic. Yeah, but I'm in C++ land here. There must be a way to print a backtrace in C++. So let's have a look here. Here is an invalid IP address, and it was called from network merge peers. So that is our problematic call, network merge peers. So let's see if we can find usages of network merge peers. So this one. And where is this called? Core test, network CPP. Here. Keep alive. Keep alive. So this is the place. Can I... No. Can I... Maybe just reset all changes because it's just... Yeah, let's reset. Let's reset everything. And let's add a log statement here. Keep alive. So it's in the it's something from the keep alive message. Those peers come from the keep alive message. Can I iterate them? Auto here. What does message A? Oh. Get peers. What does it return? An array of endpoints. Let's just print the peer. That. So let's... File has been changed since reading it. Oh. Let's copy that. Let's reload it again. Let's put that in again. That, okay. And let's build. So the invalid IP addresses are inside the message. This could take forever to find these issues. Building. Come on. Okay, let's run the test. Okay, what does it... So there's definitely messages here with invalid IP addresses inside. This one, for example. And now let's run it with... Let's run it with C++ runtime. What? There's no keep alive message. What? So that is a difference. So we get a keep alive message with Rust, and we don't get a keep alive message with C++. Okay, we have been searching at the... Oh. Okay, so now we know that we're looking at the at the wrong place. So there's a completely different issue here. Why are those nodes sending messages to each other? Let's go back to the test. Merge peer. Why do those nodes not send messages in C++? I don't have a good understanding yet of how the networking stuff works. Let's have a look at the merge peer again. What does this function do? What does reach out do? It calls reach out. And Defnal says the only good C++ is commented out C++. Oh, I didn't see your comment, Vivax, or Vivax. I agree, C++ should not be kept alive. Yeah, but it will never go away. We all know that. It will never go away. It's like Fortran and COBOL and whatever. There's so much code written in C++, it will stay there forever. Merge peer. What do you guys think happens here? I'm a bit confused. Spark Cypherpunk says the ideal world would have nanonodes in many languages and with small changes in behavior. Same protocol though, so I don't think Vivex from Twitch is right here. Yeah, so yeah, I agree. So it would be better if there are many implementations. I think it would make the network more secure, because if there's a bug in one implementation, it would maybe not be in the other implementations. So you could not bring down the whole network just because of one bug that is in every instance out there. So yeah. Yeah, I agree. So having multiple implementations should be a good thing. It should make the network more resilient, more secure. And it would also trigger like, or it would help finding issues of the protocol or other implementations. So yeah. Okay, so everything we did so far did not bring us anywhere. So merge peer. What happens here? So we call in the, let's go back to the test. The test says it starts a whole bunch of nodes, like 20 nodes. It starts 20 nodes and then it calls merge peer. And merge peer for each of those 20 nodes, it will call reach out, and if that succeeds, it calls start TCP. And what does this do? Reach out. It calls reach out, and let's switch to the Rust version of TCP channels, because that is where the logic is now. There must be a reach out somewhere. Reach out, here it is. What does reach out do? It finds the channel and it inserts the channel into TCP channels. And we know that the C++ version does not insert any channels, so... Huh? That's so strange. Let's print something here again. Let's reset our changes. And let's print something here one more time, like, let's say TCP channels reach out. Point maybe. And then we are here, we are looking for the channel. Find channel. And what does it do here? Error. If self find channel is some. So if the channel is there already, it says error. And then it goes into inserted, and then just say not inserted. Maybe we get some more data here. Oh, made a mistake. Format specifier missing. Oh yeah. So now let's build again. Okay. Building. I really wonder what could be the problem here. I have no clue yet. if we can get this Tokyo runtime to work, then we can slowly like make it Rust idiomatic and use the async keyword, and then we would have a real async network stack in Rust. This would be a major milestone. TCP channels. Find channel not inserted, not inserted. And let's run the Rust. Sorry, the C++ version. What? Let's keep them side by side. Oh no! I didn't want to do that. Let's go there. Let's. Nope. How does it work with that? No. Let's run them side by side. Oh, I don't have it here. Oh. Nah, then let's not run them side by side. This just says find channel and reach out. And this says find channel and it says not inserted. Why does it say not inserted? Why does it say not inserted? So this error message never appears when we use the Rust code base. Also, there are many more messages. Yeah, I wanna run them side by side. So let's just go here. And how do I run this? Can I copy this somehow with my mouse maybe? Yeah, let's copy that. Copy. Let's run that here. So here we have Rust. Oh. Here we have Rust. And here we have C++. Oh, you don't see the first line. It's there's this overlay. So, but now you should see it now. So left is wait a second. Left is Rust, right is C++. Find channel. And it just says not inserted, not inserted. It says not inserted all of the time. So we have to find out why the Rust code says not inserted. And the C++ says inserted. So let's see what are the conditions where something like this is not inserted? Or can we just go to the top and maybe it tries to double insert the same channels? Where's the first? Okay, let's clear the screen. Clear. Let's run it again here. Let's run it again here. And yeah, there's many more log statements on the Rust side. Oh, the log does not even go far back enough. So let's write it into a file. And let's look at the file. Okay, we get these not inserted messages pretty soon. So the first channels, they get inserted. Which one was not inserted? What was the first not inserted message? For port 36991, and it was double inserted. Can we search here for 36991? Yeah, it does for some reason. So, okay, I think I know a bit more now. So, this not inserted message, we get it because the channel was already there. It was already inserted, and that's why we get the not inserted. Underfnal says, does it return the error boolean when it should? Yeah, so we see here that it tries to insert the same channel again and again and again, and of course that fails because the channel is all inserted already. So the question is, why does it try to insert the same channel multiple times? And if we have a look at the C++ side, here it just does, it inserts each channel only once. So there's just these handful of messages. Each channel is just inserted once. And then we go to the Rust side and we get multiple inserts of the same channel. Why? Why do we have multiple inserts? That's really strange. Inserts. Why do we have multiple inserts? Do we have... What about the reach out? Do we have more reach out calls on Rust than on C++? Yeah, we do. Who calls reach out? Okay, we have to switch to the C++ side for this one. TCP channels. This is in TCP. Let's TCP. Where is this in TCP CPP? Yeah, here it is, reach out. Who calls this? Who calls this? Who calls this? So these are the tests, they are not relevant. And there is this call in network list. I don't see a reach out call here. What? The search results are wrong here. Merge peer. There's this merge peer place where we reach out. And I think we added print statements here before. And who called merge peer? Bootstrap. Let's add. Did we have a print statement here before? Yeah, I think we did. Let's print something here one more time. Bootstrap initiator. Calls. Merge peer. And yeah, let's build. have we changed here? Reach out, find channel. Yeah, let's also like get rid of these old log statements here. Not inserted. They are in TCP channels RS. Let's open that up. TCP channels RS. I just want this not inserted. I want to leave it in. Okay. Still building. Okay. Still not having the feeling that we are getting anywhere. Oh, this is so annoying. This is so annoying. Are you asleep yet? Chat? Oh, I built all tests. Now it's linking slow test and stuff. I don't need that. And if not, I'm lost but not asleep. Yeah, same as me. I'm also lost but not asleep. Yet. Oh, now it's building RPC tests. Oh. I'm also lost. Like, I have no idea what the problem... What could be the problem here, huh? Let's run the Rust tests. And... yeah. Did I not remove the print lines? Let's see. Git diff. Let's have a look at git diff again. So now we have a print line from not inserted, and we have a print line for bootstrap initiator calls merge peer. So let's make one test. If I just keep going, I will find it. But it could take a long time. Okay, now I get all of these not inserted messages. And on the C++ side I get no messages. No messages? That's strange. I thought we would maybe see bootstrapped initiator calls merge peer. Do we have the bootstrap initiator merge peer on the Rust side? Let's open the test log. Bootstrap. No, we don't. Whoa. Okay. So again, this is not the right way. So we never go to this place. But who else calls merge peer? Let's go there again. Who else calls merge peer? Oh yeah, and the keep alive. Yeah. We were here before. The keep alive. But the question is, why do we get a keep alive message? Maybe we can go to the place where the keep alive message is sent. And where would that be? I think it is in Rust already. Let's go to Rust. And let's find the keep alive message. And let's find the references of that. So just for function interface. Is there any place where we create? There's the deserializer. TCP channels here. Ongoing keep alive. The ongoing keep alive in TCP channels creates this, and it does, and then it sends that stuff. So send list TCP. So let's add a print line here. Sending keep alive message to TCP dot remote endpoint from, let's also add the local endpoint. And so should we remove the not inserted message? Yeah, because this is just bloating up our logs. Let's remove the not inserted message. And let's build that. Maybe we see a difference now between C++ and Rust. So my hope is that we get the log sending keep alive message only in Rust and not in C++. So there's a lot of sending keep alives. And there's not a single keep alive message being sent when we use C++. Okay, so why is that? Why is that? What could be the reason? Keep alive? Ongoing keep alive. Who calls the ongoing keep alive? Maybe let's also remove this print message here and just say on print ongoing keep alive. Because even that should not happen in C++, am I right? So while this compiles, okay, it's done already. Ongoing keep alive. And let's run the same thing. C++. Oh, okay, C++ does the same. I did not expect that. So both C++ and Rust go into here. So that means the send list is empty in Rust, in C++, and it's full in Rust. Let's say send list As len. And let's add the len. Send list len. Oh, there's a comma missing. So maybe that's a difference. Maybe the send list is, for some reason, it's empty on C++, and for some reason it's not empty on Rust. Send list is empty. No, now it's not empty. What? What? How does it look here? So on C++ it stays empty, and the send list just is... let's run the Rust test one more time. But... oh, that is weird. The test failed already here. And after the test failure, the send list gets... froze. So that means the send list is empty both on Rust and on C++. Ongoing keep alive. It's an empty list in both cases. But where was the place where we add the peers? Random fill peers. New with peers message. And here it is. I thought we would end up in here. I thought we would send the keep alive messages. Let's add a print line again here. Sending keep alive message. I thought this was no one, so we did not get this log message for C++, but we got it for Rust, right? This truly is the most boring stream I ever made. Sending keep alive messages. But the sending... Huh? But all of the messages, the sending message stuff is after the test failed. I think I'm looking at the wrong place. What? What? So I think this is not the right place to look at, because that sending of the keep alive message, it starts. Let's simplify the test. I should have done this in the beginning. I should have commented out the places, the parts of the test after that we are not interested in yet, because these lines trigger the sending of the keep alive messages. So I should have commented it out earlier, actually, because I think if we build now, we should see a similar behavior. Yeah, I was... Ah, that was confusing. I was looking at the wrong places for the error, because the test went on and... Let's run it again. So now Rust says... Huh. What? And C++ says... Oh, that's so strange. Why does the Rust side start sending keep alive messages? But it only starts sending them after the assertion failed with the network size. I'm out of ideas. I am out of ideas. I am out of ideas. This makes no sense to me at all. So it fails here, and then after this failure it starts to send them messages. But that means let's add a print statement one more time for when we insert channels into the TCP channels. So there was this insert somewhere here, and let's add a print statement here one more time. Inserting channel into TCP channels. And that's also at the endpoint. Where is it? TCP channel. Remote endpoint. Spark says, test is testing more than one thing. Yeah, oh yeah, you are right. Let's talk about this, yeah. As evidenced by the second assert line length, it has side effects, yeah. So that's also like a pain point I'm having with the tests. First of all, they are not unit tests, they are end-to-end tests or system tests or integration tests, call them however you like. And they are very so they don't give a good feedback, so they just fail with timeouts or whatever, and they don't help me. So they do help, because if they fail, I at least know that something is wrong, but I have no idea what is wrong if they fail. And they test more than one thing, that's right. And they are slow and brittle, because many tests don't always succeed, and sometimes they, yeah, it's not clear why they if the test failure now means that there's a bug, or if it's just a test failure that happens from time to time. Sending keep alive message. Here's the insertion failure, and here's all of the inserting channel into blah 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 blah. If we run the thing on C++, we don't get any logs. Oh. And here we get many inserting. But we found out that this inserting channel comes from Keep Alive messages. So that was... Is at the sending of the Keep Alive message, or is this just like a race condition? Is the logging of the Keep Alive that the message was sent, is that just... It's just the logging happening afterwards, and the sending happens earlier. I want to take some notes because I'm pretty sure we won't find the issue today. Spark says, feels like they were written after what they test. They don't treat it as a black box, depending much on internal implementation. It's the worst of both worlds in case of unit integration tests. I agree, fully agree, Spark. Yeah. So that's also something I'm trying to change while I bring it to Rust. Is I want to get rid of most of those. Let's call them end-to-end tests or system tests or integration tests. I want to get rid of most of those. Let's call them integration tests. Because they test more than one thing, or they test the whole node. I want to get rid of most of them because they are not as helpful as focused unit tests from my perspective. Of course, there will be some left, but I want to have the majority of the tests as unit tests that just focus on a small unit, like a small, very focused thing, and if they fail, I know exactly where I have to look for the issue. And yeah, that's also like I've been working on, and I'm really happy with how fast they are. So if we go to the Rust folder and we say run tests, so this will now compile the test. This of course takes a bit of time, because the Rust compiler is not the fastest. So let's just wait here and see. Now, once they are compiled, they run really, really fast. See? Yeah, so that's my goal, to have super, super fast tests with very specific feedback if they fail. And to get rid of all of those integration tests, or most of those integration tests. But I'm happy they are here, because if there were no tests, I would be in a much worse condition. So what should I do here? What should I do here? Should I take a break? Because sometimes taking a break is the best thing you could do. It happens to me all of the time. I'm stuck at a problem, I take a break, I come back and I find it in 5 minutes. That happened to me so often. Just a fresh perspective. Send and keep alive. It does all of... I want to take some notes because I'm working on this tomorrow. So let me just write down. So there's... so first of all, test name. The test name is GMX TCP attempts. Okay. And the problem is that in TCP channels, insert is called only in Rust, not in C++. And the insert is triggered by keep alive, right? That assumption is correct. Yeah, so that it is the keep alive that causes the channel to be inserted. Am I right? was the keep alive. But what is I find so confusing that in our logs here, the sending keep alive logs, they happen afterwards. Let's log. So we have the sending keep alive. Let's also log receiving keep alive. Was it here? Oh, and also process message. And this is the start TCP receive node ID. So both of them were called, if I remember correctly. When is start TCP receive node ID being called? In this function, in async connect. Start TCP. Oh, let's also write a print line here. Start TCP called. I just want to see if we get to this point on the C++ side. Spark, do you have a good idea how I could be more efficient in debugging this? Because I feel this print statements is just the most basic level of debugging there is. I think there must be way better. There must be something way better to find this bug. Something much faster. What would you do? Building. Why is it building so much? Check initial calls, merge period. Spark says, I'm old school too, so I use print statements. So, okay, I'm not the only one. But you can write additional tests to cover for some hypothesis. Yeah. Yeah. Oh, there's a technique actually that I used in the past, and I liked it a lot. And the name was SAF squeeze. And a SAF squeeze is you write a test that fails, like ours. We have a test that fails. And then you inline the code bit by bit. So you just inline the production code into the test just by copying it. So if your code would call a function, you would go to the function and copy it and just paste it in your test. And then you would delete all of the code that is not relevant for the test. And you would just keep on doing this, like inline delete, inline delete, inline delete, and then you would end up, if you keep doing this, you would end up with a very simple test where it was very obvious why it fails. And I've done that in the past and I liked it. But I have not done this here with Nano because I have two programming languages and I cannot easily inline from Rust to C++. And Spark says, I like TTD, so I write tests before I code stuff. Yeah. Oh yeah, me too, actually, me too. But not with this Nano project, because that is existing code and I'm trying to bring this over to Rust, and I'm using the tests that we have already here, and I'm writing tests, unit tests for the stuff I ported to Rust. But with this particular problem I'm trying to solve here, like switching from the async runtime from C++ Boost to the Rust Tokyo runtime, yeah, I haven't found a way to do this in smaller steps as I'm doing right now, because I guess you joined the stream later. So in the beginning of the stream, I made a sketch of how I ended up here. Oh, where is it? Here. And the red is the C++, the green is the Rust, and I brought all of the business logic to Rust concerning sockets, and the actual reading and writing to the sockets was done by callbacks back into the C++ side, which would use the boost async, boost IO context. And what I did now is I wrote a second implementation of this socket facade, which is just delegating all calls to the boost stuff, to the boost side. And I wrote a second implementation, and it would try to behave in the same way as the boost async library, but it would use Tokyo. And that's what I do here. Like, I run it with the tests. I run the same tests, once with the C++ runtime and once with the Tokyo runtime, and for some reason the Tokyo runtime just behaves differently. But yeah, maybe I should write tests first. Maybe I should abort what I'm doing here, and I should write many tests for the TCP socket facade, and I would run those tests against C++ and Boost and against Rust and Tokyo. Maybe, yeah, maybe that would be a better approach. Because obviously those two implementations behave differently, because that's why we have these different results. And they don't behave differently all of the time, because there are also like many tests that succeed. Undefnal says, to be fair, this diagram is the only thing that sheds some light of what you're doing on the street today. Oh yeah, I should have shown it more often. Yeah, what I'm doing here is I'm testing, like, maybe I also give that one a different color. So, and let's give that a different color so we can, yeah, so let's keep that one. Too many colors in here, huh? Let's keep that stuff all white. Can I do that? Oh, that didn't work. Async runtime. Ah no, this one is the C. Let's make this red, because this one is the C++. So I'm making C++ red, and I'm making this one. I make this green because this is the new Rust implementation, and this and all of that. Make it white. Yeah, so I think now it's, with the colors, it's more obvious what I'm doing. So this is red because this is for the, yeah. So I run the same tests against two implementations. The red boxes are the C++ Boost implementation, and the green boxes are the Tokyo Rust implementation of the async stuff. And this is very badly written, so it's I just threw together some code. So this is just was a starting point where I just wanted to have a spike, like just having like an experiment to see what would happen. And I was surprised that, let's say, half of the tests actually pass when we use the Tokyo runtime. But there's still some behavior difference that causes yeah, half of the tests to fail. And I was hoping that maybe with the stream today I could get to the bottom of this and find out what the difference is. But that was not successful so far. So Spark says, I don't have experience with Rust, so I can't help much. I want to learn it properly and start writing some PRs in the future. Yeah, learning Rust is definitely worth it. Is like, even if you don't end up using it every day, just learning the Rust concepts are a really good thing for every programming language. So it will change the way you think about structuring your code in a good way. Yeah, so maybe I should just abort what I'm doing here and actually write some tests for the Tokyo socket facade, or just some tests that I can run directly on the socket facade. So I could use the Boost socket facade and the Tokyo socket facade, and maybe I could find differences there. I was hoping so much to find it with the existing tests, but yeah, it's just a lot of stuff happening, and to find the right place is really difficult. Okay, chat. I call this a failure. I tried to find the bug, couldn't find it. But it was, yeah, as I said, I'm not a good debugger at all, because I don't have much debugging experience. If you have any ideas how I could work more efficiently here, like a better approach or better tools or anything, please let me know. Like, go to my Discord. So there's this the RS Nano Discord, and if you go to rsnano.com and you scroll down a bit to community, there's a link to the RS Nano Discord. If you have any ideas how I could do this in a better way, please join the Discord server and tell me. Because I'm frustrated now, and I want to stop the stream. I want to stop the stream. I feel like I'm running in circles, not getting anywhere, and I think I should look at this with a fresh mind tomorrow. Or maybe I should actually write tests for the TCP socket facade directly. Yeah. Okay. So guys, on Saturday, I'm on the podcast, the Nano Community Initiatives from Carlos. And really excited about that. And yeah, trying to stream next Tuesday again, but the usual time, like in the evening, 7:30 UTC. And if now says it's more than 2 hours, it was fun though. Yeah, how long is it? Yeah, 2.5 hours roughly. I wanted to stream even longer, but I don't feel like this is going anywhere. So I think it would be just wasted time. And I want to sleep. I want to take a good night's sleep and think about how I could approach this problem in a better way. Because you're just adding the print statements here and there and not finding anything. Yeah, I mean, eventually I would find the bug, I'm sure, because the most important thing is just to not give up, to just keep going. And if you just keep going, you will find the issue one day. But there must be a better way. There must be a faster way. Yeah, I wanna sleep, and maybe I find a better way, or maybe you find a better way. Please let me know. Thanks for watching. And oh, you know what? I did not do any giveaways today. Want to do some? Post your nano addresses in chat, and I'll send you nanos. There won't be. I don't think we have that many viewers right now, so just post your nano address, and I'll send you nanos. There won't even be a lottery. And if now says, see you all in 1 week, lol. Yeah, post your nano addresses, I'll send you a nano. Sir Crypto Stories? No, what is it? Hello, just came here to watch this streaming on YouTube from Perceive. Love your workflow, although I have no experience with Rust. Oh, thanks. I'm just a beginner on programming. Yeah, we all were beginners once, and we still are beginners, depending on the tech. So yeah, thanks a lot. Yeah, okay, Nano address is coming in. So let's go to Nalt and let's send one to under null. Lock. And let's send one to Spark. Oh, one. There you go. Crypto says, wait, yeah, okay, I'll wait. Also nice to see Spark here. Spark. Okay, so Spark, you're known. Cypherpunk BR. Let me Google you. Can I? Yeah, I don't find. So, Crypto, I'm too late. No, you're not too late. I can keep the stream running for 5 more minutes. So if you post the Nano addresses, I will tip you 1 Nano. Yeah, I started streaming way earlier today than usual, and but it's just an exception. Like next week, it will be the old time again. So, hello, pal, says Crypto Stories. And oh, I got a donation. 30 nanos. Wow, thank you, guys. That's nice. Thank you so much. Okay, just giving a few of those nanos back here. 1 to Niush. There you go. 1 to Cryptor. There you go. So quick. Sending nanos is so... Oh, you didn't see it. It didn't see it. So I just sent a few more. Yeah, you're welcome. Like Nano is there to be shared. And yeah. So if there's any watchers now wondering how to get the Nano address for the next stream, just download Nautilus. It's a cool app. Oh, what is this? These searches results. Okay, they should work on their on their search engine ranking. So this app here, Nautilus, a cool wallet for your mobile phone. Download that and it will show you your Nano address. Or you could also use your browser and go to, like I do here, like to go to nalt.cc, and you can just create a web wallet here. And Nano is the light, as Wendelson used to say. Okay, guys, that it wasn't fun, to be honest. It was horrifying. I hate this debugging stuff. I really do. Let's hope I find the issue before the next stream. And we can do way more interesting stuff then. Okay, guys, was nice. See you, and have a nice evening. Bye, guys.